In this video, we will see what is standard error in statistics. Now, consider a population, and from this population, if you want to get any statistics, you will take a small sample, and this table gives you the total number of samples that you can have. If your population can have k number of samples that can be taken from it, and we list them all as T1, T2, T3 and up to Tk. So these are the different statistics that we can take from the various samples that we can have from this population. This is called sampling distribution. And let's assume that x1 bar, x2 bar, xk bar, these are the means that we infer from each of these corresponding samples. The population mean is represented by mu, and the sample mean which we find from each of the sample will be different from the population mean. The sample mean can be greater or lesser than the population mean. So the sample mean can lie in a deviation line both on the positive side or on the negative side. So it will rest on this array. x1 bar, x2 bar, all of them will lie on this array here. Now this is called the deviation from the mean. Okay, so this kind of deviation that the sample mean will have from the population mean is called the error that we would get. And in statistics, how much of error we can tolerate. So this term is called standard error. And let's see more facts into this. So the standard deviation of the sampling distribution of a statistic is known as its standard error, abbreviated as standard SE. The standard errors SE of some of the well-known statistics for large samples are given below, where n is the sample size, sigma squared is the population variance. So for any sample size of n and a variance of sigma squared, we have some inference here. So this table gives you how to calculate standard error for different statistics. For example, sample mean, the standard error is sigma by root n. And if it's observed sample proportion, so which means you have dependent variables p and q. If p occurs, q will not occur. So such proportions standard error can be given by square root of pq by n. And similarly, you have a whole list of standard errors. So we will study more in detail as you go into each of these topics. Now, let's try and do an example. A server channel monitored for an hour was found to have an estimated mean of 20 transactions transmitted per minute. The variance is known to be 4. Find the standard error. Okay, so for 1 hour, the channel was monitored. So our sample is 1 hour. It's a duration of 1 hour. Okay, and then they found that an estimated mean of 20 transactions per minute. So within this 1 hour that they monitored, which was n is equal to 1 hour, they had the mean as 20 per minute. That's our x bar, that's our mean. And the variance was known to be 4. All right, so they want us to find the standard error. So let's put them in order. So our variance, which is sigma squared, is 4. And so we can call sigma as 2. Then our n is 1 hour. It was monitored for an hour. And our x bar, which is the estimated mean, is 20. So we know from the formula that the standard error for sample mean is sigma by root n. So sigma is 2, n is 60 minutes, so we put 60. So we get 2 over square root of 60, and that's equal to 0.2582. Let's do another example. Find the sample size of the given standard deviation 10 and the standard error with respect of its sample mean is 3. So you're given the standard deviation here, and you're also given the standard error, which is 3 with respect to sample mean. So you need to find the sample size. Okay, so given our standard deviation sigma is 10 and our standard error with reference to mean is 3. So we know that the standard error is sigma by root n. So for this, substituting the value, standard error is 3. So we put 3 here. Sigma is 10. So we put 10 here, and we have to find the n, so we leave root n. So cross multiplying, root n is equal to 10 by 3. Then if we square both the sides, n will become 100 by 9, and that is equal to 11. So the required sample size would be 11.
In the next example, a die is thrown 9,000 times and a throw of 3 or 4 is observed 3,240 times. Find the standard error of the proportion for an unbiased die. So we need to find what would be the standard error of the proportion for an unbiased die here. All right. So now our sample size is 9,000 because we throw it 9,000 times, and our success is known as either getting a 3 or a 4. And here we have noticed that out of the 9,000 times, 3,240 times we had success. We got a 3 or a 4. If the occurrence of 3 or 4 on the die is called a success, then with a sample size of 9,000, number of success was 3,240. Then our sample proportion can be this 3240 over 9,000. Okay, it's simple logic, it's just proportion. So sample proportion is 3240, which is getting a 3 or a 4, and the total number of times the sample size is 9,000. So the proportion for the sample is of success is given as p is equal to 0.36 by simplifying this. Now let's find the proportion of the population. So the population proportion of, or which is equal to the probability of getting a 3 or a 4 when a die is thrown. So what's the probability of getting a 3 or a 4 when the die is thrown? The probability of getting 3 is 1 over 6, and the probability of getting 4 is 1 over 6. So since it's a 3 or a 4, you need to add them up. So it becomes 1 by 6 plus 1 by 6, which is equal to 2 by 6, and that is equal to 1 by 3. So you have your population proportion as 0.3333. Now similarly, we can find the proportion of Q, which is for failure. So if P is equal to 0.333, then Q is 1 minus P, which is 1 minus 0.3333, and that's equal to 0.6667. So since it's proportion, we're talking about proportion, P plus Q will be equal to 1. So to find Q, you put 1 minus P. Now let's apply the formula for standard error for the sample proportion. And the standard error for sample proportion is given by the formula square root of PQ over N, where P and Q are the population proportions and N is the sample size. So when you draw a sample of 9,000 and P and Q are the population proportions, then the standard error is given by this formula. So solving, you get 0.00496.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions. and do not forget to subscribe to get more videos like this.